Okay, so right now what we're going to do is we're going to walk through a CAPM question, which really focuses on formula and missing variables. In this video, you're going to see how I would actually practice and identify information and use the tools that you'll be able to use on your exam. This is probably the best way about practicing for exam questions for an intro to finance class, and also probably the best way to go about solving these problems on an exam. So before we even begin, I'll tell you about how I break down these questions. Number one, obviously, is to have your formula sheet with you at all times. It doesn't have to be the same as the one I have, but it should definitely be a formula sheet such that you're able to go find the information you need as soon as you start doing the question. Number two is reading the question. Then from there, we're going to be able to pinpoint or identify the formula we need to use. Once we know the formula, we know exactly what we need to look for, exactly what we need to compute for. And it's as easy as that. That's how you solve an exam question. And that's how you practice and really make the most out of your study. And you actually get to know the information, like know what you're doing. So let's get into it. In this question, we're seeing that we need to review the following information on Microsoft and PepsiCo. So two stocks that we want to kind of get a sense of what they're up to. All right. Then Microsoft, we tell you that it has a beta, okay, of 0.93 and an expected return of 12.8%. On the other hand, PepsiCo has a beta of 1.28, all right, and expected return of 9.16%. Okay. Then we're asking you, what would be the risk-free rate have to be for these stocks to be correctly priced according to the CAPM? What does that even mean? Okay. We're telling you what is the risk-free rate, and especially what is the risk-free rate in order for these stocks to be correctly priced according to the CAPM. A lot of information, honestly, a lot of information. And we're going to leave the screen like this just because I want you to be able to look at both sides of what I have on the screen, which is the problem as well as the formula sheet, because we're going to use that. So already from the very get-go, it's quite obvious, right, that we're dealing with a CAPM question. I feel like that's probably one of the first things you want to identify, such that you know, well, on your formula sheet, what do I actually need to use, right? Now, under CAPM, there's only one formula that you actually care about, and it's the one highlighted right here. I hope you could see it properly. So K is equal to RF plus beta times the market risk premium. In the description below or in my resources or on my website, you'll be able to find this document and you'll have all of the different tools you need in terms of a formula sheet. What we're going to do now, and what you should do when you're doing these types of questions, is you're going to write the formula at the top of your paper, your sheets, your iPad, whatever. Okay, so we're going to write that CAPM, okay, the formula could be simply written as K is equal to the risk-free rate plus beta times ERM, the market index, minus RF. That's amazing news. Now we know exactly which formula we need to use in order to go through this problem. Now, what I would really recommend you to do is to highlight the stuff within your prompt that's actually in your formula. Because once again, in these chapters, in Intro to Finance, and honestly, throughout all of your university or CGEP or higher degree, whatever process, you will only need to solve for the missing variable. It's always a puzzle. And typically, because they're not lunatics on an exam, they're going to give you some of the pieces of the puzzle, and then you're just going to have to solve for the remaining piece. So that's what we're going to do now. We're going to identify all of the pieces that we already have from our CAPM formula, and then we're going to identify the ones that we don't know just yet. Okay? So we're going to begin by using, I guess, the color red. We're going to highlight the pieces of the formula we have in yellow, just for whatever. So if we were to look at Microsoft, we know that the Microsoft's beta is going to be 0.93. So we understand that. That's amazing news. We know that the expected return on Microsoft is 12.8%. So we know ER for Microsoft, so I'm going to write MI, just for you not to mistake the two, is equal to 12.8%. And then we could do the same thing for PepsiCo. just because they're different companies, I guess I'll use different colors. But PepsiCo has a beta of 1.28. So you could write beta P is equal to 1.28. And the expected return of PepsiCo is equal to, you could write ERP is equal to 9.16%. Okay, so if we were to look at our formula, I guess we'll highlight it in red. We know right here that we have our beta, okay, for Microsoft. We don't have our expected return on the market. Honestly, we only have our beta and the expected return. So we could say probably the K of Microsoft. We could do the same thing for PepsiCo, in which we notice that, okay, we have the K, which is going to be the expected return. I'll tell you why in a second. And we have its beta. Obviously, what we're going to highlight, I guess, in orange, which is the unknown, is essentially the risk-free rate, the return on the market, and once again, the risk-free rate. So there are two unknowns, okay? But really in this question, we're asking you, okay, what is the risk-free rate? That's really the biggest unknown that we really care about, the risk-free rate. How do we know that? Is because the question literally says, what would be the risk-free rate have to be? I guess there's a problem in grammar, but that is common on your exams. The wording is going to be kind of strange. So what has the risk-free rate have to be in order for these assets to be correctly priced? Okay, so we're solving for the risk-free rate. We're solving for a particular risk-free rate, a unique risk-free rate. Okay, the one that's going to allow for these two stocks to be correctly priced according to the CAPM. Now, what the hell does that even mean? All right, well, I'll tell you what this means. So what we're going to do is, I guess, I didn't think about this too much, you know, going in forward, but I guess we're going to take a screenshot of the right-hand side of our little formula, of our little, you know, SML, so our CAPM formula, and we're going to just stick it on our problem sheet right here. So we'll do that just like this. That should be kind of helpful. Okay, and we're going to make it pretty big, put it right here. So, and with that, I guess we're going to have to zoom in just a little bit, just for you to really understand why this matters. Okay, so what is the capital asset pricing model all about? In other words, what is CAPM? CAPM is a very unique and cool way to solve for the rightful price of an asset. Literally, the title of the CAPM stands for the Capital Asset Pricing Model. In other words, it's a model that allows you to price assets, okay? In other words, we're really going to compare that K, right? According to the CAPM, K stands for the appropriate, okay? The appropriate rate of return for any given level of systematic risk. Okay, that's what it stands for. What the heck did I just say? Beta, which is what you see right here on our x-axis for our CAPM formula / SML, is essentially a very particular measure of risk. In fact, measures systematic risk. And when we plug that in within our formula, right, if you remember right here, plug that in within this formula, for any given level of beta, right, for any given level of x, you will receive k, which is going to be your dependent variable, essentially your y, okay, your y value. And k will be the appropriate rate of return for any given level of risk. What does that mean? That means that that's going to be your required rate of return, okay, for taking some sort of risk. The higher the risky, like the higher the risk of an investment, so the more risky it is, the more return you will want, okay? So I usually have a very ghetto example when I do my courses or my weeklies or whatever, but I will actually abstain for doing so. I'm gonna avoid the cringe. But really, what you want to understand is that the more risk you take, all right, the more you should be compensated, okay? Now, that's one idea, and it's gonna be very important in just a second. The second idea I'd like to share is what is the relationship between K, the required rate of return, and ER, the expected rate of return. These are slightly different topics, okay? So we're going to write them down right here. And all of this is just to give you context, such that if you are on an exam, because questions are never the same, although they could be, you would have the I guess, the context, the perspective, the frameworks, and the models to be able to solve any problems related to this. So hopefully this gives you context. But to go back to what I said, there is K, which we know is the required rate of return. And then there is the expected rate of return, so ER, okay? ER on any asset, so the expected rate of return, okay? K is a very specific rate of return because that's the rate of return that is provided by the CAPM, okay? Once you plug it in our famous formula that we had up top right here, you're gonna get K. That's a very specific expected rate of return. It's what you require for any given level of risk, okay? There's only one amount that you would require for that level of risk. And that's all it is. Whereas an expected rate of return, that could be a little bit subjective. That could be a lot of things, okay? Expected rate of return, it could be based on past prices, right? It could be based on data analysis. We did this in chapter 8, which is portfolio theory. But could it also be based on anticipation? It can be based on anticipation, on what you believe. So anticipation, beliefs. In other words, it can be quite subjective, okay? And sometimes K and ER will not always be the same, okay? In fact, there's 3 scenarios that could happen between K and ER. It could be that K is bigger than ER. It could be that K is equal to ER. And it could be that K is actually smaller than ER. Now, the implications of these 3 different buckets will be described more so when we do questions on pricing assets. But right now, what I want you to understand is one specific instance of the relationship between K, the required rate of return, and ER, the expected rate of return, okay? And that's the middle one, the one that we're gonna highlight in yellow right here. That's the one at which the expected rate of return is equal to the required rate of return. And you know what's hilarious? That specific instance, we're going to actually call it an instance where, it's funny, these stocks are, and I'm sure you guessed it by now, these stocks are correctly priced, okay? Are correctly priced. A little smiley at the end. So the final bit that I want you to understand is that if stocks are correctly priced, they're going to lie on our CAPM line, on our SML. They're going to lie right here, okay? If they're correctly priced, and I guess we'll use our little information just to make it maybe more visual. Remember that, and I'll zoom out just a little bit to make it more visual again. Remember that our Microsoft stock had a beta of 0.93. So if beta is 1 here, we could say that Microsoft is probably right there. So we're going to call this MI. Okay? And we said that PepsiCo had a beta of 1.28. Okay? So it would be right here. This would be PepsiCo. Okay? So as you can see, PepsiCo would essentially require a higher rate of return, right, than Microsoft because its risk is higher as well. Its risk is much bigger than that of Microsoft. So you would require a higher rate of return. And in other words, I guess, or in comparison or alternatively, I don't know, can't speak English, you would see that Microsoft requires a smaller rate of return because its risk is smaller than that of the market and that of Pepsi. Do you see the relationship? It's pretty awesome stuff. And the last bit that's important to understand, and there are several videos that I made on this on my YouTube channel, but what I'd like to say, the last bit, okay? And I spent a lot of time talking about this, but all jokes aside, the SML, which is the security market line, in other words, the formula for CAPM, it's a linear function. In other words, it's quite literally y is equal to mx plus b. And you can see this highlighted right here, okay? And what does that mean? This means that m, which is the slope of our linear function, is our market risk premium, okay? In other words, it's the relationship of, not even, I could make it simpler. It's your risk premium. It's the additional returns you require for taking on risk, okay? And you'll see why that's important in just a second. So what I'm gonna do is I'm gonna just make some stuff a little bit smaller so we have some space to kind of, actually solve some stuff. So I don't know how I'm going to make this smaller though, realistically. So I guess I'll bring it to the top right here on some cringe stuff. If you saw the video, you know what we talked about, so that's not a problem. And we're going to zoom in, okay? And now we're actually going to solve the question. That was 14 minutes of like introduction to the problem. But it's very simple. If we say that assets are correctly priced, now you understand that they lie on the SML. Now you understand that they're going to get essentially a level of return per unit of risk that they take, okay? Because we understand that for every single unit of risk you take, you will require some additional returns, okay? In other words, this is something that kind of looks like the Sharpe ratio. We could actually look at it like that. And we could coin it as being the rate of return required per unit of systematic risk. Okay? So in other words, how much additional returns are you making over the risk-free rate per level of risk that you take? And this should be pretty like straightforward for you. Beta represents risk. So I guess we'll put it in yellow. This represents systematic risk. Okay. RF is the benchmark, is what we want to beat, because if we're going to take on risk, right, we need to at least pass the risk-free rate, because risk-free rate is what we can make without taking any darn risk. So we want to beat that, okay? And then obviously K, which is going to be our required rate of return. A required rate of return, okay? Now, the reason why I'm showing you this is because once we understand that, we could actually make it super easy, because we know we have K for both Pepsi and Microsoft. We know we have beta for both Pepsi and Microsoft, and we know that the risk-free rate will be the same between the two. So what we could do is we could just make them equal to each other, do a little systems of equation, and just solve for RF. In other words, solve for a missing variable. In other words, solve for X. So that's exactly what we're going to do. So yeah, I guess we'll have enough space right here. I know it's kind of hectic. I apologize for that. So we know that K, Microsoft, MI, minus RF over beta of Microsoft will be equal to, in this case, I guess we'll leave it in the same color, the K of Pepsi minus RF over the beta of Pepsi. So we know that if we take, in this case, I believe I forget the amounts, low-key, so I'm going to zoom out a little bit. So if we take 12.8% minus X over 0.93, and that's going to be equal to 9.16% minus RF over 1.28, we're going to get RF. It's as simple as that. Now, I'm not going to go through all of the algebra, but I will tell you what the answer is, okay? Now, I'm going to use my classic friend Excel, because it's just simply the best way to go about it to solve for this question. And you know, it's funny, this is the first time I've ever done this question. Like, I just made it, so we're going to have to wait for me for 2 seconds to actually compute the last step and solve for our missing variable. And in this case, we will see the risk-free rate is maybe kind of wrong. Let me see. Does that make sense? It could be. I mean, listen. It could be this amount. I got a strange amount, but we're going to go with it. And I'm going to verify it one last time. Microsoft 1.28 for Pepsi. Hey man, we got a weird amount. We got 22.472%. We're going to go with it. And even myself, who made the question, I even get sometimes thrown off of the answer is not as cute as it should be. But on an exam, that's very possible. And you'll have to deal with that. So just like that, this is how we solve an interesting question on how to solve for missing variables such as the risk-free rate on an exam question. Hopefully this was helpful. Do not hesitate to leave a comment if there's a mistake. Do not hesitate to let me know if I was a fool. I'd be more than happy to help you out. This is for free, meant to help you out once again. So